recorded as of now. We'll cut this so you can just get the very beginning, but in about 2 minutes we'll start. We strongly encourage questions. It helps others, believe it or not only you, because people often have the same questions on similar topics, especially if they come in it at the same level of experience or proficiency in the subject. So no question is a silly one, as we all know. It's the ones you don't ask that are the silly ones. So appreciate everyone's participation. We'll get going in another 2 minutes, and I'll do again, my usual 1.5 to 2 minute spiel so you understand, for those who have not participated, what we do. And again, all the follow-up in terms of the content, how do you get the certificate, by completing the exam, et cetera, will be reviewed now, but also will be sent to you, so there's no ambiguity, and we hope you have enjoyed the program thus far. So just give us another minute, we'll get going. Okay, everyone, it's precisely the top of the hour. My name is Paul Siegel from StarWeaver. This is Intrusion Analysis with Kevin Cardwell, who will be taking over shortly as the presenter. I'm going to do a very brief introduction to StarWeaver, because I think many of you know us, but I think it's incumbent upon me to make this presentation and tell you a little about what we do for a living. I think for those who have participated, we do training. We do training for large corporations and individuals around the world. We use the tagline, education you can bank on, because a lot of what we do is in the fintech area, but as well, we want you to understand that the education is predictable, it's reliable, and it's all practitioner driven. We work for large organizations. These are some of the many. We've worked with most of these for a decade or more. And thankfully, we've had very good feedback and very good follow-on. What we do is live and in person. We have 750 courses that are in the online recorded libraries that we have, but also we do live and in person, live and recorded. I was just mentioning to Kevin, we're doing a Python and Lettuce program up in Connecticut today, and tomorrow we do an AWS program. So every day of the week, we are doing training somewhere in the world, and it is either in one of these 5 areas: cutting-edge technologies, enterprise, traditional enterprise IT, project management, agile, Scrum, Lean, Kanban, et cetera, and finance and banking, derivatives, corporate structure, capital structure, corporate valuation, et cetera, and business skills. We do this in multiple formats. As I mentioned, here's an example of one of the video-based recorded programs online, we try to make them as interactive and practitioner-driven as possible. We do have a bit of a retail component, if you will, that is enabling individuals such as yourselves. Here is the CyberWarrior CyberWarrior certification program you're participating in. Capital market immersion is available, as well as is a Scrum and Agile Ready program. This program, as I think you're all aware, is 7 parts. They're recorded and made available to you. There's a short test at the end, 25 questions, all randomly drawn, so none of the people in this webinar will really be getting the same questions or in the same order. You can pause, you can come back, and you'll be able to pass with a 70% score. All this detail will be provided to you, and you will get a certificate from the Institute designating your completion. I think we're all aware of these 7 components. We're up to the intrusion analysis piece. I think you've seen the prior have been very detailed. Again, video recordings will be made available. Again, we're up to May 17th, 11 a.m., intrusion analysis. You'll see here, and then intrusion handling next Tuesday, and that'll wrap up the program. This is the link. I will provide it again on the right once Kevin gets going, so you can see that. You'll again get links to this, plus you'll get access to a learning management system when you get access to the test. Kevin will tell you about himself. I think he's been really well presented, how clear and knowledgeable he is on the subject, so I won't take that any further. There are other upcoming webinars, not only today's, but We have one coming up on next week in addition to the CyberWarrior on DevOps. We have a whole series of FinTech talks that are going to be announced in the next week, as well as a TOGAF program. So I recommend that to you. Again, these are the courses you can get for free if you just complete the survey. So just do that. It's in the right link. Here's the contact information. Always send an email to helpdesk@StarWeaver if you have any questions. And with that, I'll pass it over to Kevin and wish you a great program. Ask your questions, please, on the right. It's easier to do it that way than to make it an open mic. And we'll field them and make them, Kevin will be able to answer them as you're ready. Take it away, Kevin.
Okay, thank you, Paul. And as this is coming up here, I'll go ahead and say, yeah, the main thing is I've spent 25 years as a professional security tester, and part of that was I was with the U.S. Navy with the project brought internet access to ships at sea. So as you can imagine, what we're going to cover here in this section, intrusion analysis, was something we had to do once we started connecting military ships and military commands to the internet. Now, we weren't very smart back then. That was 1991, and whatever the name of the ship was, that's what we called this domain. So all the hackers could see the name of the ship and the domain and know that that was the U.S. Navy ship. So that was a pretty big problem with that. So let's go ahead and get continued here. So what we want to do is talk about intrusion analysis. So to do that, we need something to be able to detect the intrusion. And the most common thing to use to detect the intrusion is intrusion detection. All right, so what exactly is intrusion detection? Well, what happened was we realized we needed something to monitor what's taking place on our network. So what happens is we have to take and have what we call like a closed circuit TV of our network. And that's because we know our security controls aren't perfect, but we have to verify what works and doesn't work. And that's kind of where intrusion detection came out. Intrusion detection came because we needed something to tell us what was going through the network. Now the problem is, as we'll see, is the definition of it. In intrusion detection, you got to remember, we only know it when an attack has occurred, occurring, or has already taken place. So that's why intrusion prevention came out. So we've got the fortress mentality, and that's pretty much what most of us design our networks on. There's nothing wrong with this mentality, but remember, the firewall acts as a gate. So when you go through the firewall here, anything that happens over in here, the firewall knows nothing of. So it's example I like to use of a door. If you go up to a door and there's security at the door and you hand identification or some type of method to get through the door, once you get through the door, the only way the actual organization knows what you do after you go through that door is if they have closed circuit TV. So intrusion detection is the same concept. Intrusion detection is monitoring the network to see what's taking place once we've gone through our perimeter defenses, our perimeter security, all right? So that's really where intrusion detection came from. And remember, when we get an intrusion, we've talked in the different webinars about different things that could happen. And you know, the ransomware spread is a good example of that. We're going to have network traffic that identifies that. So what we do in intrusion detection is we want to make sure we analyze either the network or the host to determine if an intrusion's taken place. So your policy defines how we actually set up our intrusion detection. A lot of people forget that the simple security policy is still the key. Why is that? Well, as a consultant, when I go in, I need to see your security policy to know what you allow and do not allow in your environment. So if I start testing things you're not supposed to allow in a network segment, for instance, if I test that and it works, that means something happened. Somebody's made a configuration change or you're not enforcing your policy. Your policy still is your definition of your data, right? And this is where we get into this discussion on your data, and your data should never be on the same network segment as your users, because you can't do that today, because we've already seen with all the ransomware attacks and everything and stuff like that, because users are always going to be the weakest link, and we've already talked about how a user can click, right? So for intrusion detection, we take this security policy and we code it into the rules and the configuration for our intrusion detection system, and also intrusion prevention. We'll talk about intrusion prevention just a little bit, because it's really just a component of intrusion detection that they changed the name of, in my opinion. But the escalation procedures determine how your intrusion detection will respond, and we'll talk about that, because today we call it intrusion prevention, but believe it or not, intrusion detection's always had the response capability of it, and we'll discuss that coming up. So we have two main types of intrusion detection. There's a third one called network node, but we'll cover these two main categories: host-based, network-based. And as you can think about it, the focus of the host is what's happening on the machine, and the network's the focus what's happening on the packet level. The problem is defining the packet level, because we have large networks. Big data is here. So when we have big data, you have this challenge of all these packets on the network and those types of things. So we have to analyze what's taking place at the network and start thinking about how many network packets are going over your network now. And they're doing an AWS type of class, webinar, those types of things. All this cloud environment, that's data. So all this data is traversing your network. So network-based IDS has to handle that data. So what's going on in your network? Monitors and detects, but does not prevent, right? You can use it to prevent, but instead we've made intrusion prevention systems for that. And we're going to talk about that. And we used to be able to, and you still can, do a thing called harden the firewall. But we're going to talk about why there's a problem with that. But it's a complement to a firewall, but it's not a perfect solution. There's no silver bullet, magic bullet, however you want to do it. But the most important thing is that bottom bullet right here. It requires extensive monitoring. I like to use the analogy, it's like having a pet or a child. You constantly got to take care of that pet and that child. That's the thing with the intrusion detection system. You can't just put these things in and then just walk away and leave them. You actually got to monitor them and make sure you understand what you're looking at. And that's kind of where the focus is when you start doing protocol analysis and those types of things, is to understand intrusions. So in the next webinar, we'll actually walk through an intrusion and then an incident response for an intrusion. And another problem with network intrusion detection, and specifically the amount of network traffic, is false positives. The problem is we can't determine busy traffic from a denial of service attack. And this gives us a big problem when it comes to monitoring our networks, because there's just too much data. And you kind of know that today if you're doing any types of analysis or incident response where you go back and try to determine what's happened. We have so much data on our network. As I said, big data is here. Now we have to monitor it. So it's a real challenge. And what happens is an intrusion detection system will suffer for these things called a false positive. So you got to make sure in your organization, they being whoever's in charge of the intrusion detection system, monitor it and do what we call tune it. You have to tune the intrusion detection system. A well-configured intrusion detection system will not have any red alerts in it. So that's how I identify intrusion detection systems tuning. I'll go into an organization. If I look at their intrusion detection system sensors and they've got red alerts all over the place, they haven't tuned it, because you should know what the red alerts are. So when you see a red alert, that means something's happened that you got to go pay attention to. All right. The problem is if you've got too much red, you never know what to respond to. So it makes it very difficult, or the cry wolf syndrome is what we like to call that. There's three main functions of an intrusion detection system. You have monitor, which we've talked about, detect, we got to analyze it, determine out what's taking place, and then respond. And that third component, the response, is the one that's always been there. And we'll discuss that, because today we call that intrusion prevention. But it really was always a component of IDS, intrusion detection systems. It just wasn't software built specifically for response. It would monitor, detect, and respond. And we'll talk about each of these. So a monitor in a network situation, you have to get a promiscuous mode network card. That means you have to turn off the MAC address filtering of the network card and allow all traffic to go into the actual sensor. And how you identify the potential attack traffic is comparing the traffic to patterns or signatures in a database. Now we have a couple different ways of doing this. There's nominally, there's all kinds of algorithms out there, but the same concept is there. We have to take a pattern or a known behavior and compare what we're receiving to what that pattern and known behavior that we've stored in a database is. So what we have to do is we have to analyze these and look for signatures of attack traffic patterns, so you can get an idea of what's taking place. We got to take all those network packets in, assemble them. So the packet reassembly is a huge process. Once we reassemble these, we have to determine what's taking place on the network. And this can be very time consuming and a challenge. So we take every packet, we reassemble it, and we identify patterns. We're only as good as the latest signature. So just like with vulnerability detection, a lot of these other types of things, we got to have a signature update. If we're not up to date on our signatures, we're behind and we'll miss attacks. And that's kind of where we're at with intrusion detection. So when a new zero-day vulnerability comes out, Unless the vendor's created a signature for it, you have to go out and create your own or wait for the vendor. And that happened with ransomware. Shortly after ransomware came out, all the vendors started releasing the signature for it, but it had already attacked. It had already hit networks, those types of things. So again, it's always reactionary, and that's one of the concerns with everybody. And then you got response. Now, when you think about response, you got to think about, do you trust the software to do and analyze all this network traffic? We've already talked about the amount of network traffic on our networks. Do you trust software to be able to do that and then respond? Is software that mature? And the answer is, you're trusting software to know it's an attack. Personally, coming from a software engineering and design background, we still don't have software that smart that can tell you what attack or busy traffic, or maybe it's just an actual anomaly, those types of things. So this is a big challenge. And the problem with the whole process is, and the problem with intrusion prevention is, how do we block the traffic once we do detect that we determine we believe it is an attack? The most common way to block the traffic is to block it by IP address. Now think about this for a moment. I block by IP address. Well, I think it's kind of easy. Everybody out there listening probably knows I can change my IP address relatively easy. In fact, I have an old, when I do a actually a denial of service attack, when I show an old denial of service attack, I have software that literally was developed originally in 1994. It was just updated in 1997, and it still works today. And even that software that long ago has an option to randomize your source IP address. So don't think a response to block by IP address is an effective response. It's not. Another thing is, what if I spoof the IP address of your default gateway and use that against you? Think about this. If I go on your network as an attack and send an attack, and your IDS is, or your IPS same way, is set up to respond, and it responds and blocks the IP address. Well, if I put the IP address your default gateway, I just denied service to your entire organization. So you gotta be careful about this. Now the vendors have gotten a little bit smart on this, because what they'll do is they'll actually let you put in an exclusion list. So you can put in your own IP addresses, like your default gateway, all this type of stuff, as an exclusion now, and then it won't block that IP address. But again, understand intrusion detections all work by what we call a threshold. So as an attacker, when I train people in advanced penetration testing, those types of things, I can stay below that threshold. If I stay below that threshold, you never detect me. And that's kind of what I want people to understand. Yes, it's a deterrent. We need them, but you're always going to be able to get past it if you get a sophisticated threat, because they will lab it up, put it in a lab environment, and figure out what works to get past it and what doesn't work. And that's always what you got to remember with this response feature. We want our IDS to be passive. Well, what do I mean by that? If I've got my intrusion detection system on a network and it's in a promiscuous mode network card, I want that network card to only receive traffic, never generate traffic. Because if you remember some of the attacks we've talked about, we've shown some exploits, those types of things. To work, I have to get traffic out of the actual victim. And we have, in the past, found vulnerabilities in intrusion detection system software. Remember, intrusion detection, intrusion prevention, it's all software. Software will have vulnerabilities. So we've actually taken an intrusion detection system that was not set up as a passive device, and we've successfully exploited the actual sensor, and then we were using the intrusion detection system to attack the network. So again, if you allow it to be active on the network, it could get a vulnerability and could potentially be used as an attack vector on the network, as we've done with the popular intrusion detection system several years back. So we want a passive device, and passive means it receives traffic but never actually generates it. So how do we do what we call this passive IDS? Well, another term for that is we stealth the IDS. The old way of doing it was we unbind the network card. Now, those of you who've been around software long enough know when you unbind a network card, no problem. Everything works fine, except you'll install software or some other software will actually bind the network card back. So when you unbind the network cards, you never know if it's going to stay in an unbound state. Unbound means there's no IP address on it, right? You only need the physical address to get data to it. Those of you who have been done RJ45 termination know you got transmit and receive pins. I can cut the transmit pins. So if I cut the transmit pins, it can't transmit. So nothing can transmit out of that machine. The problem is, if I cut the transmit pins, I get that famous little statement some of you have probably seen, network cable unplugged. That network cable unplugged is because it checks the state of the connection now. So because of that, cutting the transmit pins no longer works. I can loop the transmit to receive side of the cable, and you can buy special cables for this, and all that does is the transmit goes out and loops back into the receive, so you never actually have the transmit, the data never goes out onto the network, which is a great way to do it. And then anybody out there listening, if you've played with electronics, I can put a capacitor in line and detune the transmit signal so it never gets out of the actual machine either. All four of these are methods to stealth and IDS. And then what you do is you put another means of management in. So normally what we do is we put another network card in, and we use an actual cable-to-cable connection if you can, a direct connection. That's the safest way for out-of-band management of the sensor. And that means no matter if my network gets compromised, my management of that sensor is never on the network. Nobody can impact me talking to that sensor. So this is a powerful way to do your intrusion detection and also your intrusion prevention. We will say, for the sake of time, we won't spend a lot of time in intrusion prevention where they overlap, because they overlap in a lot of areas as well. So this is one of the things you have to remember. You put an intrusion detection system, and some of you out there that's listening to this, if you've ever done this, what happens is the thing goes off and alerts all over the place, right? So you got to tune it first. Make sure you've tuned it, it's well tuned, and then when the IDS alerts you to an attack, okay? So I've told some in the other webinars, and I thought now, when we put ships on the internet, we would see 50 to 100 attacks an hour. Now this was early 90s, so it wasn't as bad as it could have been, but 50 to 100 attacks an hour. And in that 50 to 100 attacks an hour, we would actually try to analyze what's the nature of the threat. What level of threat is trying to attack us? So we would do that by looking at a number of factors, and we'll show packets on that here coming up, an image of that. But what it is the IDS did its job. So what do you do now? Number one is don't panic. We like to use the saying, crawl to conclusions. When we first put intrusion detection systems on ships and we would tune it, we would leave, some admin would get in there where they were at sea, change the settings, and all of a sudden they'd have all these red alerts and think they were under attack. But a lot of times it was false positives. Many attacks turn out to be false positives. That's why you have to tune it, and no matter how much you tune it, there's going to be still some false positives. Once you determine that it's not a false positive, like the people who had the ransomware attack, those types of things, assemble your team, prioritize your task. And this is the key, and this is why we talk about network segmentation in the other webinars as one of your fundamentals of defense. Because you start a complete surveillance process. If it's in a segment, you're going to monitor that segment. If it's in the firewall area, those types of things. So once you've got the indication of the attack, isolate the attack, identify the attack, and start increasing your monitoring and go through the entire process of what's taking place on the actual machine. That's what we want to do when we do complete surveillance. And then you might go and even escalate that above that. You're going to examine the traffic from the particular source that caused the alert. What protocol is being used? Is it using a protocol that makes sense? Ransomware was using server message block, right? So a server message block is trying to go out to the internet. That's not right. You should never see SMB port 445 going out to the internet. That's a dead giveaway that something's wrong on your network. And then when you see it coming in and seeing thousands and thousands of packets coming in, that's another dead giveaway something's wrong coming into your network, right? Those are the types of things you want to use. And then look at Icmp. Is it got Internet Control Message Protocol? Are there commands inside the Icmp data packets? HTTP tunnels. What we mean with that is it a protocol that says it's HTTP, but when you look at the packets, it's not a GET request. It's not a head. It's not the things that look like HTTP traffic. It actually, in some cases, I've got indications where people have tunneled FTP over HTTP or SSH and those types of things, right? That's what you want to look at. Look for the commands and data transmitted. Can you read it, or is it encoded? If it's encoded, start trying to look at different types of things to decode it. Maybe you're lucky and it's a simple base 64 encoding. That's much easier than an actual encryption. If it's encrypted, then it's going to be very difficult because you got to get a key or try to decrypt it, just like you do with CryptoWare and all this other type of stuff that we've been running into. Okay? Identify the direction of information flow. Is it all predominantly inbound? That is, like with the ransomware attack as an analogy, it's all inbound because all the packets came into the system as, the worm spread. That could be the inbound ratio. Or is it outbound? Outbound means one of your users has clicked, double-clicked, and done something, and when that user's done that, they've activated the worm or the infection, and the infection's going out to the internet. So by identifying that, you know immediately, yep, it's an inside victim. Oh, it's still outside of us. Well, if it's outside and it's just coming in, and you followed the concepts we've talked about throughout the entire webinar series, and even talked about the last webinar, the ingress filtering. So if it's all coming in, but it's ingress, which means it's on port 445, it's the WannaCry and the ransomware that's recently made all the news, you're not susceptible to that. Yeah, it can flood your external connection, but the packets are not coming in. As long as you know your ingress rules only allow, say, port 80, port 25, those types of things. If the attack's coming over the surface message, or the server message block protocol, the SMB protocol, on port 445, and you don't allow that in, you're not under that risk. Right? So that's where that ratio of packets is key. That ratio of packets will tell you if it's an outside threat or is it an inside threat, or is it blended? Do you have the same amount outbound and inbound? If you do, then you've been compromised, and the data going back and forth, you could be participating in the case of ransomware, the actual WannaCry bot, or you could be part of another botnet, right? Those types of things. That's how you have to identify it. But the frustrating thing for most of us who are on the defense side is simple fundamental security controls that we've already talked about throughout the series, the ingress filtering, the egress filtering, black hole routing, those types of things, and the internal decoys and triggers, none of this takes place. Or if it does, you identify the infection. As soon as you identify the infection, you isolate it, and as I like to use, and I've used many times, the disease analogy, you lose patient 0, but you never get a patient 1, and then we win in defense, right? Identify the host being targeted by the attack. And sad to say it, but if they're targeting your client, isolate the client. Your clients shouldn't have any sensitive data on them. If they do, then you've got a policy problem, right? And your data should be separate from your clients and your users and your workstations. We've discussed this already. Don't let it ride on the same actual segment. What do? You start logging everything. And I mentioned this before in the network segmentation. We all know there's going to be systems. Some of you out there still might have Windows Server 2003. Some of you might have Windows XP. They're out there. They're still out there. So what you do is you put all those servers on one segment. So you know that's your critical risk segment. So you already should have sensitive monitoring, increased authentication, and stronger authentication as much as possible on that segment to still meet the business and mission need. So what you do is you start logging everything on that specific host that you're seeing in your logs of the intrusion. Expand your signatures. Monitor as many signatures as possible, right? Make a copy of the host logs. Start thinking of the isolation and taking that machine off and doing forensics analysis of that machine, right? Those types of things. Analyze the data leaving your site. See if it has even distribution of content. As I said, is it random or is it a steady stream of data? Just noise. What is it? What are they doing? Is it ASCII? Is it encoded? Is it encrypted? Is it binary? Try to analyze what's taking place. This is part of your process for your intrusion analysis. And we're going to repeat this in the next webinar, the last webinar, because we're going to follow this same process, but we're going to give a scenario of an actual incident. Go to a higher level of surveillance. Capture all traffic to and from the target or the attacker. Start looking at the source of the attack. Is it randomized? A good attacker is going to randomize their IP source. So if it's not a randomized IP source, you're getting lucky for one thing, but you're probably not going to have that sophisticated of an attacker. Somebody's just out there running tools at you, right? Capture the traffic, expand your logging traffic to include auditing of processes. That's one of the things that's extremely difficult to do is audit your processes in memory. But once you have this type of indication of an intrusion, you want to turn on actual memory and RAM-based process analysis if you've got it. If not, you want to start considering taking snapshots of memory and dumping information from a specific process if a process is identified as potentially malicious, or you want to go and do other things, right? So those are the keys, and those are things we'll talk about in the incident response as well, right? You want to know what programs are running on your system. Because if you get lucky, they'll run something and show it to you. Now, if it's really sophisticated, a kernel level hack, those types of things, they're going to, if they're a sophisticated threat, they're really upper threshold type of attack, they're probably not going to show you what they're running. But again, you can still identify it with access to what we call handles. So if it accesses the registry, if it accesses file systems, you can use a tool called Process Monitor for that. There's another one out now that's getting a lot of good feedback called Sysmon. All these are from Microsoft, who bought out the Sys internal suite, but all these types of tools will allow you to get more information on the intrusion, and that's what intrusion analysis is all about. Stop the attack. Okay, well, this is where you get into a gray area, right? You detect it, right? That's half the battle. You stop the attack, yes, but don't launch a counter-offensive, and that's what we're talking about right here. And the reason for this is, unless it's a very amateur hacker, and I'm saying this as straight as I can be, regardless of what you hear in the news or anything like that. Unless it's an amateur, low-level skill set hacker, not a really sophisticated threat, their source address is going to be the real source address. But nobody would do that has any background on attacking. You would either make it an address to pretend like somebody else is doing the attack, not like I'm implying anything here, but you also could actually run it through a Tor proxy. And when you look at the WannaCry, it does set up the Tor proxy, which goes through a bunch of different IP machines before it gets to you. So be careful about launching a counteroffensive, because remember, just because you were attacked doesn't give you written authorization and permission to attack the source of the attack, even if you've got it right and correct, because there's no gray area. You can't attack somebody without written authorization and permission. If you do that, now you're as bad as the malicious hacker, all right? Decide whether to disconnect the target. Sometimes you want to leave the target online, so you've got to figure out different types of things to do on that. So like I said, look at who the victim is. If the target's a workstation, you know there's nothing sensitive on there, you can probably leave it open, just isolate it where the traffic goes to and from that machine and make sure it doesn't spread. But if it's a data server, those types of things, you probably want to take it offline immediately to try to isolate and see what damage has been done, what's actually got off the network, those types of things, right? And we've already talked about the IDS products with the response feature, and the response feature being actually block the IP address. So what is intrusion prevention? Well, as I say, a lot of people have different opinions on this, but intrusion detection always had monitor, detect, and respond as its three main components. So the response feature really is intrusion prevention. So to me, it's no different than what we've always had, but we have software dedicated to it now instead of doing the three functions: to monitor, detect, and to respond. Okay, so what it is we know we can't prevent vulnerabilities. I wish we could, but I keep telling everybody we failed at software testing. Why are we doing all this software testing, but we still have vulnerabilities? But that's another topic for another time for sure. Identify potential attacks. That's what the intrusion prevention is doing. So what it's doing now is it's trying to isolate processes, memory access. It's trying to do all this before the attack. Remember, intrusion detection, even though if somebody says it's real time, it's not truly real time. The interaction is still going to be a delay because the processes are actually already happening. With intrusion prevention, since we're isolating process or we access monitor programs or deviations from expected behavior, all of those are methods we can do real time and prevent the actual attack, right? So we can identify anomalies and events, right? And once it's done that, it still has false positive problems, all those types of things, but it can process or isolate that processor memory area and say, you know what? This isn't looking like it's working right, and then it can terminate it. It's kind of what Microsoft offers us now starting with Windows 10 Enterprise called Device Guard. So if you go out there and look up device guard, it's a similar type of thing. And Microsoft now in Server 2016 actually does containers. So to take memory and put it in a little container, a different privilege level. So the privilege level is the key here. If you give too much privilege, and they did originally with Windows kernel, and we won't get into that and all that type of stuff, that too much privilege is why we have a lot of the problems we have today. You either were a user or a kernel memory. So, right, those types of things. Problem with all this, just like intrusion detection, human interactions required to validate and verify that attack. You can't trust this to ever be 100% accurate. So because of that, you're going to have a team. And this is where I get, because you read my background and look at the details or search on the internet, you'll see I set up the first commercial security operations center in the country of Oman. And when you have to explain to them, because we did that 5-6 years ago, quite a few years ago, and now everybody over there is putting in a security operations center. And I know a lot of you probably are too, because I see all kinds of people doing it all the time. And I do that. I've put in different ones. I put the one in for the Navy in Europe, all that type of stuff. But what I want you to understand is human interactions required. So yes, you can put all this stuff in, but you got to have trained teams to be able to monitor it and maintain it. And that's where people make the mistake. And that's the problem you get. Everybody's putting in these security operations centers in Middle East, North Africa, all those types of places. But when they're putting them in, they don't realize they got to have staff to maintain it and monitor it. So it's a little bit of a challenge, because you can't throw products at this problem. You have to have trained personnel, and it's not more personnel, it's trained and job skill specific training. So that's the thing. Okay, so the same as we had in intrusion detection, we have mainly in intrusion prevention. We have host-based and we're network-based. In the host-based, right, we're looking at system logs, operating systems, and applications. Your event viewer, right? Event viewer is one of the best places in a Windows system to go look at what's happening on the machine, because the event viewer usually will log suspicious things that happen on the machine, especially since Microsoft's getting better and better at this type of stuff, right? So the host-based is looking at that system log, that operating system, that application to see what's taking place at the host level. So if you want to write an actual network signature, because network-based is looking at all those packets, so what we're doing here is we're showing you a network signature of how you would use Snort to detect something. So it's pretty easy when you look at it. Alert tells you the action you want to do. So it's going to generate an alert on a TCP protocol, not equal, so this exclamation point is the not sign, 10.1.1.0. So not equal to this class A address, right? Going to this class A address. So that's saying as long as nobody's internal in my network going to this address on port 111, this is the port right here, 111, with this content, external mount D access. So what it is somebody's trying to externally mount a machine on your inside network. Your inside users, this is okay, but this should never happen from the outside. Just this one simple rule will show you anybody ingressing and trying to mount port 111 or connect to port 111 on any machine on your network. And that's how simple it is to write a signature. But the problem is if somebody connects to it normally that's not in your local network, but they do it as a means of their business, this will still generate an alert. So this will generate an alert for anybody other than the actual local network that connects on port 111. By doing that, this could cause you problems because it could be a lot of false positives. And that's why you have to tune it, right? And that's why network intrusion detection, network intrusion prevention is so difficult, because we have so much network traffic that we have to deal with, right? So that's how you would write a signature in Snort to detect it. In the demonstration, I'm going to set up Snort. I'm going to show you the simplest setup of Snort that I've ever seen, and it's a free tool that does it. So your network traffic, and we're just going to review, if you don't remember, you have Icmp, you have UDP, you have TCP, right? In Net Control Message Protocol, UDP, the connectionless protocol, and TCP, the connection-oriented protocol. So in intrusion analysis, I have to be able to look at this traffic and determine what's taking place, okay? Icmp is testing different types of conditional messages and transmitted in IP. Everything's encapsulated in an IP. So you have a header with the Icmp message, and in that header it tells you the type of Icmp and the code of Icmp. This is critical because there's certain types and codes of Icmp you should never see on a modern day network. One of them is ICMP type 5, which is the redirect. If you get an ICMP type 5 on your network, it's suspicious, right? ICMP type 3 code 13 means your Cisco router is telling somebody it's blocking with an access control list. All these types of things are identifications of something's going on in your network, or your administrator's made a mistake and is showing something on the network that you shouldn't. Remember, less is better. So never give up error messages, ICMP, unreachables, all that type of messages to anybody who queries from the outside world in your ingress filtering. Okay? UDP, very simple header, very simple protocol. Why? Because there's no connection, connectionless. It's set up to send actual information without setting up a connection. And then here's what the UDP packet looks like. So when we look at it here, this is a domain query. You see lots of this stuff, right? Domain port 53 and UDP. And you see the actual transaction ID, the resource records, those types of things. This is what it looks like at the actual network level. So when you go into intrusion analysis, you can start to understand, what do you need to understand? You got to understand protocol analysis. So you got to know what looks normal and then be able to deviate and analyze what's abnormal, right? That's what intrusion detection and intrusion analysis is all about, is analyzing what's taking place at the packet level. And that's what my Udemy course is about, teaching you how to use Wireshark to understand all this stuff. Okay, TCP, stream oriented. That's because there's no actual acknowledgement required. We set up two sides of connection. We got a half open on one side, a half open on the other side, and we get two sides of connection. Stream oriented, it's got flags that indicate the components of the conversation. Hackers like to use illegal flag combinations. So that's what you have to understand now from an intrusion analysis standpoint. You have to look at these and understand what's normal and what's abnormal, right? And this is what, when you have that security operations center, or if you're part of a SOC, this is where you have to start. You have to start at the packets, TCP/IP. That's why the actual first webinar we have, I believe, was on TCP/IP and the foundations and fundamentals of security, right? And that's why, because you have to understand it, and everything takes place on the network that you see, all right? So what are these flags? Well, we've got 6 flags here: urgent, ACK, push, reset, send, and fin. I think I cover them again later, but I'll cover them here now too. Urgent means the pointer is set. What normally that means is I've got data that please don't buffer it, send it directly into memory. Acknowledgement, I'm acknowledging something you sent. Push, there's data in the packet on the push flag. Reset, abnormal close. Send, open a connection with me. Fin or finish, it's actually close a connection, right? But remember, hackers use these illegal flag combinations, so keep that in mind as we start going through here. So a simple way to identify the operating system, remember I told you we would see 50 to 100 attacks an hour when we would put warships and military ships for the Navy on the network. Well, a simple way back then, because ping, there was no tools back then, there was no Nmap, there wasn't all these cool tools. So a ping in Windows is 32 bytes of data, and it's alphabetic, as you see here, A through W lowercase, and it just repeats. In Unix and Linux, 56 bytes, or some of them 48, of data, numeric and special characters. So when you look here, you've got it right there. That's just a crude, simple way if somebody's pinging around the network, because you remember we talked about the methodology when we talked about the scanning methodology in the previous webinar. If you've seen that, if you haven't, you can see it when you go look. The first step of the scanning methodology is live systems. We got to find something that's live to attack. We can't attack something that's not there, right? So that's the process we do with that. So that A through W lowercase, and then the numbers and punctuations help us identify if somebody's pinging our target. It helps us identify if they're actually a threat or not. Because I'm sorry, I hate to, but most sophisticated attackers, or especially in the early 90s, wouldn't come at us in the Windows environment. They would be using Unix or Linux, more Unix than Linux even back then. They'd be using Unix to come at us in a attack mode. And if it was Windows, we put them in a lower priority queue. Because if it's Windows, most sophisticated attackers are not going to look at and go with Windows, okay? All right, so I got a demo coming up. But I want to say something real quick in case I run out of time, because I always run out of time. But I want to add one more slide before I do the demo slide and explain to you my methodology of analysis. So this methodology of network analysis, first thing you do is look for suspicious, anything suspicious, right? And from an intrusion standpoint, I want to know what's my open ports. What's my open ports in the network trace? If I know the open ports in the network trace, then I can actually look deeper into it, because if the port's closed, there's nothing that could have had an intrusion, right? Next thing I want to look for is the data, right? The next thing I want to look for is identify sessions. And like I said, I don't know if I'll get time for this or not. We'll see. And the last thing I look for is signs of intrusion, okay? And I covered this in great detail, and it's a question. I mean, you can always ask a question later. I can give it to you. It's in my Udemy course as well. But again, that's your methodology, step by step. Look at a network trace, look for anything suspicious. Well, what's some suspicious things? I already told you. If you know in your network segment that you're monitoring and you're looking for intrusion analysis, and you know you should never see port 445 traffic, we'll use the WannaCry ransomware, and you see it, that's suspicious. Then you want to check and see open ports. See if anything in the network trace shows, hey, not only did they look for port 445, they got a response that said port 445 was open. And then look for data. And look for data and see what's actually being taken from your network. Remember, all the packets that have compromise will have data in them. So we do that with the push flag, and I'll talk about that in a moment, right? Those types of things. Identify sessions, right? Signs of intrusion, okay? These are the types of things that we want to do in our methodology, right? So what happens is when we do these types of attacks, we send in an attack as an attacker. Now I'm putting my attacker hat on. And when I put that attack in, I'm looking for a response. If your tool or whatever doesn't respond the way it should, I've found a way in, right? And that's why I said the methodology. I do the hacking methodology. As long as I do the hacking methodology, I can look at the network traffic and see exactly what it looks like. So all throughout this webinar series, I've showed a lot of different things. So what I encourage you to do is take Wireshark. There's tutorials everywhere. You know, look online. There's my books. There's my courses. There's others. There's lots of things out there. You can connect to me on LinkedIn. I can help you figure out different things to do. No problem. But what you do is start running Wireshark, doing network packet captures, and when you capture all that network traffic, start reviewing that network packet captures and seeing what's taking place. So when we run this Xms Scan, when we run these other types of things, identify what it looks like at the network and the packet level, okay? So let me go ahead and let's do the demo and see how well our demos are working. So this is Network Security Toolkit, all right? So if you go to networksecuritytoolkit.org, yeah, it's actually a nice little tool. And what it does is, and I'll just show you here real quick, it gives you all this information. And what it does, it maintains most of the top 125 open source security tools. So a lot of cool stuff you can do there, right? So the one we're going to use here is Snort, the one I showed you how to write the rule for the Snort Network Intrusion Detection System. As you see here, it just has the interfaces. So I got ETH0 on this machine. So all I do is select the interface, right? And I scroll down, and you see the button right there? And I don't have the tools installed. That's why it's jumping a little bit. See the setup start Snort? I click. Now, this is the most difficult thing to do. You got to wait 10 seconds. So sometimes it's hard to wait 10 seconds. But you're going to have to do this twice. And it's just one of those things. It's an anomaly. It takes that long to set up the databases and everything else. So here in a second, when I click this check status, it will say stopped again. But when I do it the second time and wait 10 seconds, because you always got to wait your 10 seconds, it should be started. And that's it. And those 2 clicks, this entire Snort setup is done. And if anybody's tried to set up Snort that's out there, you know it's not the most simple thing. And about half the time, the instructions are only about 50% right. So it's a bit of a challenge to set this up. But a network security toolkit, as I said, it's still in a stop state. I do it the second time, and now I wait 10 more seconds, and then it'd be started. Again, it just takes that long to start up what we call Barnyard and all the other tools. So what you're going to see here when this comes up, we have a full-blown intrusion detection system on this machine, and then I'm going to run a quick attack so we can actually see the actual alerts. And then I'll probably have to in the webinar and turn it back over to Paul, but we'll see, because I've got a network trace here that if I got a couple minutes extra here, I'll see if I can do it. So hopefully 10 seconds has passed. That's all I want right there. You see that running? Once that's in a running state, it's done. What's nice is, do I want to go load rules? I can click on rules. I can load some rules. I can do all kinds of stuff. So we'll look at that as well. So what I've done is I've set up a Snort sensor on ETH0, right? So what that interface does on ETH0 is monitor network traffic. So I just go here and I go tail, for tail the last lines of the log, alerts. Let's see. Oh, I know what I gotta do. Hang on. I got to open another one, because what happens is Network Security Toolkit, what it does is it creates a separate interface file. So I got to go into the new one. There, now it'll work. So now I just tail -F alerts. This is the alerts log, so I'll hit it a couple times. So now all I do is generate an attack. So if I go here, desktop applications, and I'll just do it from the Network Security Toolkit just to make it easier and sake of time. And I'll put them side by side here as good as I can. And now I just run the attack. So I'll use Nmap. We've looked at Nmap a couple of times, just a simple scanner, and I'm going to use what's called the Xms Scan, right? The Xms Scan for Nmap, very popular attack for script kiddies. If anybody out there and you're doing your analysis and they're running the Xms Scan on you, then you're actually going to see, there it is. See that? There it is. Full-blown intrusion detection system, 2 clicks of the mouse. Okay? So there you go. That's it. That was full-blown. Now I've got an intrusion detection system. What I've done with organizations, and you can do in your organization, take a machine, put 5 network cards in it, and you can monitor 4 segments and have 1 network card for your out-of-band point-to-point management. And there it is, detecting the actual Xms Scan, telling you it's a Snort alert. Well, what's the Xms Scan? Glad you asked. So now I just go back to my Snort, and this is what we love about Snort, because what we've done here is with 2 clicks of the mouse, not only have we set up an intrusion detection system, we've set up a full-blown distributed IDS with graphics. So now here's base. Base actually shows you, look at that. So I've had 2 sensors on this machine, shows me my 2 sensors on that machine, the unique alerts, and I've had TCP attack traffic, UDP attack traffic, Icmp attack traffic. And all I got to do is click on this, and that shows me the actual alert log. So this is the actual alert log of Snort showing me what's taking place on the machine, all right? And when we start looking at this, I just click on one of these packets, and that's the actual packet. There's the metadata, there's the IP information. Remember, everything's encapsulated inside IP, and there's the protocol, TCP, IP protocol type 6, and 3 flags are set. In the Xms Scan, the signature of the Xms Scan is the fin flag, the push flag, and the urgent flag is set. And that's exactly what we see here, okay? So that's it. You've got a full-blown distributed intrusion detection system with 2 clicks of the mouse. And I actually showed this at the Black Hat conference years and years ago, before Kali Linux or Backtrack or any of those ever came out. So it's been out there for a long time. Go to networksecuritytoolkit.org, download it, and it'll be a little bit different now because it's a newer version. I use this older version just because it still names the interface ETH0, and I don't have it, because otherwise it comes up ETH with a bunch of names. One last thing that I'll do here before I turn it over and let Paul wrap us up here. The open ports, you have a filter. It's called tcp.flags.syn. This is in Wireshark. Since I don't have time to go through the process, I'll just give you the filters so you can go back and watch it and practice. Why is that? Because if a port's open, a SYN packet goes to the port, it responds with a SYN ACK. If it's closed, it responds with a reset, correct? Okay. Data, that's tcp.flags.push equals 1. Those 2 filters will enable you to identify everything in a network trace and see what's potentially malicious or not. And that's what I've got here real quick before I go. See all the red? all these resets, you should not see resets like this on a normal network, right? Look at all these resets. Resets are a dead giveaway that somebody's looking for something, in this case a port scan of some type and those types of things. But all I would do is apply a filter here, TCP dot flags dot, and I'll just go straight to the data. Yeah, if I can spell flags right here. Must be getting toward the end. Yeah. That's the only packets of data. So even though I had all that traffic, these are the only packets of data in that entire network trace. And remember, without data, there's no attack. Now, I like to just look in this bottom window here, but I'll just show you real quick. I just right-click one of these, follow TCP stream, and that shows me exactly what happened. And if you see this here, that was an attempt at a cross-site script against a website, and it was successful because it says 200 OK. And this is an old version of Microsoft IIS, of course. But when you see this 200 OK, that means whatever string came in was allowed. And in this case, the attack was allowed. So now we'd have to go back and investigate and see what happened between those two machines. And then did that machine communicate with anybody else? Because if they got on the machine, they use that as a pivot point, as I showed last webinar, and they'll pivot to other places. So you go to the source of the traffic for that machine and you analyze it. And now I'll turn it over for questions. And there's the information again.
Thank you, Kevin.
Yep.
Okay. Thank you, Kevin. So you see Kevin's contact information here, everyone. Hopefully you can hear me clearly as well. Obviously, this is a lot of material. So please ask questions. It is not expected that you're going to absorb this in a few seconds and then be able to understand it immediately. Kevin covered a lot. But the point here is now to open up the questions, to have you can just say, look, Kevin, back it up to the first slide. I lost you when you said X. That's perfectly fine. But let us know, because the last thing you want to leave in an opportunity where there's an opportunity in front of you to ask a question is, to let it go. So please do ask the question. Obviously, you can always ask questions of Kevin on the next program. But it's always best to ask them here. And as I said, we'll try to open the discussion forum up so you can have some questions answered before the testing. We'll show you how to do that. But again, a deep program, lots of material covered. Really appreciate Kevin's time and effort. I know there's some people who may have some questions, so we'll leave it open for another few minutes. Don't hesitate, please. As I said, you may have a specific circumstance. Again, we don't want to know anything internal proprietary to the organization. But if you do have a situation you come across that relates to this, please share it, ask questions. Kevin, I'm sure, will be able to address it. You obviously have healthcare organizations participating, financial institutions participating, and others. So.
And you can always connect to me on LinkedIn and ask me the questions there if they want to do it in a more private manner.
Exactly. Again, the link to the videos, this one will be posted within the next few hours. We'll send a link out to everyone again. Again, we'll get you access to an LMS within the next few days. So you'll be able to access both the content as well as the test questions. But again, they will not be available before the end of the last program, which is next week. Again, 2 programs this week was a lot for anyone. So I'm going to wrap it up now, but appreciate Kevin's both depth of knowledge and presentation style, which is very hands-on. Again, please, you can always send questions to the information on the screen. You can always send questions to helpdesk@starweaver.com, which I've just typed in the window on the right. And you can always get access to the content on the Vimeo link, which again is on the right, and I will attempt to resend now so that you have access to it. Again, thank you all. Great program, Kevin, once again, and we'll be back to you and send you a reminder for the program next week. Everyone have a great remainder of the week and great weekend. Thank you so much.
Thanks.